Hello guys, today we'll be talking about indices, how to represent indices, how to simplify index number, and how to solve equation that involve indices and the laws governing indices. So before we dive into this proper, we need to really know what an index number is. So from this definition, from what we see on the screen, we are multiplying a times a times a 7 times, and it can be represented as a power 7 in index notation. So we can define indices as simply a simplification of repeated multiplication by a number by itself. So if a is multiplying itself repeatedly, it becomes so cumbersome, it becomes so long for us to represent this repeated multiplication. So we decided to come up with what they call indices. So indices is simply to simplify this repeated multiplication of a number by itself. So the number of times a number is multiplied by itself is called the power, and the number itself that multiply itself is called the base. So from this, if a number a is multiplying itself y times, then we can represent that number a as a power y in index notation, where y is the number of times a is multiplying itself. In this representation of index notation, we can call y as the index, the power, or the exponent, and we call a the base. So in case in general, we can read this number as a power y, or a index y, or a exponent y. So let's consider some examples here. So they say that we should convert the following to indices or expand where appropriate. So the numbers are a half power 5, 2.5 power 3, 3p power 4, 3y times 3y times 3y, and 16. So a half power 5, we have said that what the power simply tells us how many times the number multiply itself. So a half power 5 simply says that a half is multiplied by itself 5 times. So the expansion will be a half times a half times a half times a half 5 times. 2.5 power 3 is the same as 2.5 times 2.5 times 2.5 3 times. And 3p power 4 is the same as 3. If you look at it carefully, 3 is not power 4. So we cannot say 3p times 3p times 3p. So we'll factor out 3, and then we expand p power 4, and p power 4 is p times p times p. So we are going to have 3 into p times p times p times p 4 times, where 3y times 3y times 3y. 3y is multiplying itself 3 times. So we'll take one of the 3y as the base, and then we express it to a power, and the power will simply be the number of times 3y is multiplying itself, which will give us 3y power 3. 16 is simply 2 times 2 times 2 times 2 4 times will give us 16, or 4 times 4 will give us 16. So 16 can be 2 times 2 times 2, which is 2 power 4, or 16 is 4 power 2, where 4 is the base and 2 is the power, and here 2 is the base and 4 is the power or index or exponent. So that is all about indices. Now let's see the laws of indices, and the very first law we are going to handle here is the multiplication law. For us to understand how the multiplication law works, let's consider a number 5 multiplying itself 3 times times 5 times 5 times 5 again. You know, bracket from BODMAS simply means multiplication. So we can have 5 times 5 times 5 times, instead of the bracket, times 5 times 5 times 5, which will give us 5 times 5 times 5 6 times. So in this case, 5 is multiplying itself repeatedly 6 times. So we can express it in index form as 5 power 6, correct? Again, we can see that here is 5 power 3 and in this other bracket is 5 power 3. So we can decide to say 5 power 3 times 5 power 3 because bracket is times, right? So we see that what if we add 3 plus 3 is going to give us 6. So we can say in this case 5 power 3 times 5 power 3 is the same as 5 power 3 plus 3, which is still 5 power 6. So if we accept that this 5 power 6 is the same as this 5 power 6, then we can say generally multiplication law is simply that if we are multiplying index numbers of the same basis, we add the power. Because in this case we added 3 plus 3 and it gave us 5 power 6 as the same as this 5 power 6. So generally a power m times a power n is the same as a power m plus n. So if we are multiplying two index numbers of the same basis, we add the powers. For example, let's consider this. So we should evaluate a y power a times y power b. So we are multiplying index numbers of the same base. What do? We add the powers a plus b. Another example is 2 power 4 times 2 power 8. We are multiplying the bases are 2 and 2, so we add the powers 4 plus 8, which is 2 power 12. The next example is 5 power 4 times 5 power minus 2. Again, the bases are the same and we are multiplying, so we add the powers. So we are going to have 5 power 4 plus minus 2. So plus minus 2 is simply the same as minus 2. So we are going to have 4 minus 2, which is 2. So we are going to have 5 power 2. Okay, the next law we are going to see is the division law. So we are going to again consider a number 7, and we are going to have 7 times 7 times 7 times 7 times 7. That is how many times? 1, 2, 3, 4, 5 times, divided by 7 times 7, 3 times. So we are going to see that sorry, this 7 cancels this 7, this 7 cancels this 7, this 7 cancels this 7. We are going to be left with 7 times 7, and 7 times 7 is simply as 7 power 2, right? So again, rather than using this method, we are going to still see again that 7 times 7 times 7 5 times is the same as 7 power 5 divided by 7 times 7 times 7 3 times 7 power 3. So we are going to have 7 power 5 divided by 7 power 3. And if we do 5 minus 3, we are still going to have 7 times 7, which is 7 power 2. So we are going to say that the general form of the division law can therefore be simplified as, if we are dividing two index numbers of the same base, then we can subtract the powers. That's why we have a power m divided by a power n to give us a power m minus n. So let's use this law to evaluate some common index numbers like 8 power 13 minus 8 power 5 and u power 2 times u power 3 times u power 7 divided by u power 4 times u power 5. So the first one is 8 power 13 divided by 8 power 5. So we are dividing two index numbers of the same basis. So what do? We subtract the second power from the first power. So we are going to have 8 power 13 minus 5. So that is going to give us 8 power 8. In the second example, we are going to handle the numerator first because of the multiplication, and then the denominator, and then we do now the division. So u power 2 times u power 3 times u power 7. So we are multiplying index numbers of the same basis. So what do? We add the power. So we are going to have u power 2 plus 3 plus 7 divided by u power 4 plus 5, right? That's correct. So u power 2 plus 3 plus 7 is u power 12 divided by u power 9, and if we evaluate that, is u power 3. right? Okay, that's clear. So the next law we are going to talk about is the exponential law. So let's consider again another number so we understand where the law are coming from. Let's consider this 5 power 4 all that power 2. So 5 power 4 all that power 2 is the same as 5 power 4 times 5 power 4, and if we open that up, we are going to have 5 times 5 times 5 4 times 5 times 5 times 5 4 times. All of that is going to give us 8, right? 1 2 3 4 5 6 7 8 8 times. So that is going to give us 5 power 8. Again, if we consider 5 power 4 into power 2, we are going to have, if we multiply 4 times 2, we are going to have 8, which is the same as 5 times 5 times 5 times 5 times 5, 8 times. So we are going to say that generally for exponential law, if an index is raised to another power, we simply multiply the two powers. What do we mean? We mean that a power m, all that to the power n, we simply multiply the two powers as a power m times n, because of these manipulations I just showed you. For example, let's see the example here. So let's consider 6 power 4 all that power 2. So what do? We have an index number 6 power 4 raised to another power. So we simply multiply the two powers, 4 times 2, which will give us 6 power 4 times 2, which will give us 6 power 8. If you want, you can simplify. Okay, the next example is e power y all that power x. So again, nothing has changed. We just have variables in this case. So e is raised to the power y, which is an index number, and that index number is raised to another power x. So we are simply going to have an index number e power y times x. So e power xy. So the next we are going to have is minus 2 power 3 all that to the power 4. So we are still going to have minus 2 power 12, 3 times 4. Okay, so that is the law of exponential law. So what other law are we going to see? Let's see what we call the zero law. So let's consider in this case the division law, but in another form. So let's say we are dividing an index number with the same powers. So let's say we are dividing u power 4 divided by u power 4. This is the same as u times u times u 4 times divided by u times u times u 4 times, or is u power 4 minus 4 from the law of indices that we saw, the division law. That what? If we are dividing two index number with the same base, what do? We subtract the power. So u power 4 minus 4, and 4 minus 4 is 0. So we are going to have u power 0. Again, if we expand this u power 4 divided by u power 4, we are going to have u times u times u 4 times divided by u times u times u 4 times. In that case, this u can cancel this u can cancel this u can cancel this, and this one can take care of this. And what is going to give us there is going to give us 1, right? So if this law that we accepted, that these two laws are the same, therefore we can say that what? There is another law called the zero law, which says that anything raised to the power 0 is 1. So a raised to the power 0 is 1. But for what? If a is 0, if 0 is raised to the power 0, is not 1, is 0. So if a is not 0, anything apart from 0 raised to the power 0 is considered as 1, and that law is what we call the zero law. For example, let's consider 2 into vty power 2 all that power 0. So I don't need to try to evaluate all these. Just the fact that vtu power 2 is raised to the power 0, I just consider all of that to be 1. So what I'll be considering now is that is equals to 2 into 1, and 2 times 1 is 2. right? Okay, that's clear. Here again we are going to have 1 divided by a power 0 or that power 2. But a power 0 is what? Anything raised to the power 0 is 1. So we are going to have 1 divided by 1 or that power 2. And 1 divided by 1 is 1. Power 2 is 1. 2 power 0 or that to the power 100. 2 power 0, anything raised to the power 0 again is 1. So 2 power 0 is 1. And 1 raised to the power 100 is 1. That's it. So that's the 0 law. So the other law is what we call the law of the negative indices. So let's see this law. Now consider that what? The numerator is less than the denominator. So we have 7 times 7 times 7 4 times divided by 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6 times. So we are going to have 7 will cancel 7, 7 will cancel 7, 7 will cancel 7, 7 will cancel 7. We are going to be left with 1 over 7 times 7, which is 1 over 7 squared, right? So again, if we consider the law of what? Division law, we are going to have 7 times 7 times 7, 4 times. We are going to have 7 power 4 divided by 7 power 6. And this law says that what? If we are dividing two index number with the same base, we subtract the power. So we are going to have, which is the same as 7 power 4 minus 6, and 7 power 4 minus 6 is the same as 7 power minus 2. So if we agree that these two answers are the same, then we come up with the negative law of indices that says that anything raised to the power a negative number is the same as 1 over that thing. So we are going to have 1 over a power n is the same as a power n minus a power minus n. So this law is coming from this simplification. For example, let's evaluate the following. 3 power minus 4 is the same as 1 over 3 power 4. 3 power minus 4 is the same as 1 over 3 power 4, which is the same as 1 over 81. Also, minus 2 power minus 1 is the same as 1 over minus 2 power 1. And minus 2 power 1 is minus 2. So we are going to have minus a half. So that is how we handle negative indices. So the other laws of indices are anything raised to the power 1 is that thing we know, right? So a power 1 is a. The next law we want you to know is a power a times b, all of that power n is the same as a power n b power n, right? And the other law is that a power a half is the same as the square root of a. The next law I want you to take note is a power 1 over n is the same as the nth root of a. This law is the same as the previous law, law 8, because if we don't have power a half, we have power 1/3, then it will be cube root. If we have power 1/4, then it will be the 4th root, and so on. So we can modify these two laws to have another law. A power m, all of this power n is the same as the nth root of a, all of that power m, right? So those are the laws that I want you to take note of. The 10 laws of indices that I want you to have on your fingertips. With this law, now let's use these laws of indices to evaluate the following. And the first one we are going to see is 16 divided by 81, all that to the power minus 3 over 4. So what we need to notice here first is that we have a negative power. If we have a negative power, we can consider it that what all of this was 1 over all of this, right, to clear this negative. So this is equals to 1 over 16 over 81, all that power 3 over 4. But look at what happens. We have a division with division and a division. So this can be seen as we invert the second fraction, right? Because if we have 2 division, then we invert the second fraction and we change the sign to multiplication. So it will instead be 1 times 81 over 16, all that power 3 over 4. 1 times anything is that thing, so we didn't include 1. So the next thing we are going to do is that what we can simplify this and say that what 81 over 16 is the same as 81 over 16 times 1/4, all of that power 3. So if we have 81 over 16 power 1/4, all of that power 3, we know that what if we have a power n, we have what we can multiply the two powers m times n. So if we multiply 1/4 times 3, it will still give us 3 over 4. Nothing has changed. So in this case, we can take what the nth root of 81 and the nth root of 16, and n in this case is what 4. So we can take the 4th root of 81 and the 4th root of 16. But all of that is t power 3, and the 4th root of 81 is how many? 3, and the 4th root of 16 is 2. So 3 over 2, all of that power 3. But if we open up this bracket, is the same as 3 power 3 divided by 2 power 3, right? So we are going to have 3 power 3 divided by 2 power 3. 3 power 3 is nothing but 27, divided by 2 power 3 is 8. The next example we are going to see is such equations. We call them what? Exponential equations. And these exponential equations can be handled by either using what we call equality in the base or the power. Or if it does not go, then we can change the equation to what we call logarithms. But in this case, that is what we will use. So 2 power x is equals to 8. So if we look at this equation, 8 can also be raised to can also be transformed into what? Base 2. So 8 is the same as 2 power 3. So we are going to have 2 power x equals to 2 power 3. But the law of indices says that what? If the bases are equal, then the powers are equal. Or if the powers are equal, then the bases are equal. So for us to take 2 power which number will give us 2 power 3 is only when x is equal to 3. So if the bases are equal, then the powers must be equal. So in that case, we can say that what? X is equals to 3. The next exponential equation is 2 power x equals to 1 over 4 power 3. So the first thing we can do is that what? We can change this number into what? A negative index. So we are going to have 2 power x is equals to 4 power minus 3, right? So that is that. But if we look at 2 power x, we can also change 4 to the base 2, so that we use the law of what? If the bases are equal, then the powers are equal. So if we change that index, we are going to have 2 power 2, which is 4, all of that power minus 3. So we are going to have 2 power x equals to 2 power 2, which is 4, all of that power minus 3. But if we have an index number 2 power 2 raised to another power minus 3, we said that what? We simply multiply the 2 powers, 2 times minus 3. So we are going to have 2 power x equals to 2 power minus 6. And if the bases are equal, then the powers must be equal, which implies that x is equals to minus 6. Again, the next example is that 8 power x minus 1 is equals to 16. So Can we raise 8 to the base 16? No. Can we transform 16 to the base 8? No. So we look for a number that is common. The base will be common for 8 and 16. What is that number? That number is 2. So in this case, we are going to have 2 power 3, which is 8, all of that power x minus 1. So we are going to have 2 power 3, all of that x power x minus 1, and 16 is 2 power 4. So again, we have an index number raised to another power. So we do what? We multiply the two powers. So we are going to have 2 power x minus 1 times 3. And if we multiply that, we are going to have 3x minus 3 equals to 24. Because 3 times x is 3x and 3 times minus 1 is minus 3. We are multiplying everything x minus 1 times 3, not just x alone, right? So that's why we have 3x minus 3. Okay, so the bases again are equal, so the powers must be equal. So 3x minus 1 must be equals to 4. So 3x minus 1 equals to 4. When we take x to the other side of the equation, 3 minus 3 to the other side of the equation, its sign changes to positive. So we are going to have 3x equals to 4 plus 3, and 3x equals to 7. So x equals to 7 over 3. We'll divide both sides by 3. Another example is that 2 power x plus 2 power x equals to 4. So in this case, what do we do? So the next example is 2 power x plus 2 power x equals to 4. So how do we handle this? We know that a plus a is the same as 2a. b plus b is the same as 2b. So 2 power x plus 2 power x will be the same as 2 into 2 power x. So we are going to have 2 into 2 power x equals to 4. But 2 is the same as 2 power 1. So this can be considered as 2 power 1 times 2 power x, right? Equals to 2 power 2, because 4 is the same as 2 power 2. So we are multiplying two index number with the same what? Basis. So we can add the powers. So 2 power 1 times 2 power x, we will add the power 1 plus x. So we are going to have 2 power 1 plus x equals to 2 power 2. So if the bases are the same, the powers are the same. So we are going to have x plus 1 equals to 2, and x equals to 2 minus 1, which is x equals to 1. So but here, from here, you could change it to something different. So since we have 2 into 2 power x equals to 4, you can divide both sides by 2. So you have 2 power x equals to 2. And since the bases are the same, the power must be equal, because 2 is the same as 2 power 1. So x will be equals to 1 as well. Okay, so the next question is 5 power x equals minus 600 equals to 25. So we can bring like terms together. We'll take 600 to the other side, it becomes positive. So we are going to have 5 power x equals to 600 plus 25, which will give us 625. But 625 can be in base 5. So we are going to have 5 power x equals to 5 power 4. Since the bases are the same, the powers must be equal. So we'll have x equals to 4. The next example is 10 power x equals to 0.0001. 0.0001 is the same as 1 over how many decimal places? 1, 2, 3, 4. 1 over 10,000. So we are going to have 10 power x equals to 1 over 10,000. But 1 over 10,000, but 10 power x equals to 1 over 10,000. 10,000 is the same as 10 over 10 power 4. So we are going to have this as 10 power x equals to 1 over 10 power 4. But 1 over 10 power 4 is the same as 10 power minus 4. We know the law, right? So 10 power x is equals to 10 power minus 4. So again, the bases are equal, so the powers must be equal. So x will be equals to minus 4. So guys, that's how we handle questions on indices and logarithms in this case. So if you have a question, don't forget to leave on the subscription button or contact us direct. We also have a WhatsApp group. If you want to join, leave a comment on the comment section and I will guide you how to join it. And before you go, we are going to leave you with an exercise, which is this for you to attempt. So guys, attempt this exercise, and if you have any question about it, then you contact me. So good luck with it, and you can leave your answers at the comment section and I will tell you if it's right or wrong, and then we can make a video if you have any challenges. So stay with me and stay with It's Maths Time question and answers on YouTube, Facebook and Instagram. Like, subscribe and share my videos. Bye bye.